Hello, welcome. Today we're going to be looking at environmental exposure and risk analysis. Following heavy disasters in places like Pamex, Bhopal, Chernobyl, Piper Alpha, Bright Spanglers, Fukushima Daiichi in Japan, Petronas, Phillipsburg in England, there comes the need for what we call environmental exposure and risk analysis. How we check hazards and try to curtail the effect, the impact they have on human beings and the environment. If you check the history, you see that the disasters or events that took place in Pamex, Bhopal, Chernobyl, Piper Alpha, Bright Spanglers, Fukushima Daiichi in Japan, very recently, nuclear meltdown, very bad. Petronas, Phillipsburg, they were very disastrous. They led to loss of life. They led to loss of heavy and huge amounts of money. We don't want things like this to be happening. So because of that, we're going to be looking at hazards and how to curtail hazards. Now, there are three major types of hazards that we can have in this world. We have what we call fire hazard, hazard that is caused by fire, explosion, and toxic release of materials that are not good to the body and the environment. Now, for fire to happen, three things must be involved, and that's why we have what we call fire triangle. Three things must be involved. Number one, you need to have what we call oxidants, like oxygen or any oxidant. You need to have what we call fuel, like hydrocarbons, wood, anything. And you also need to have a spark, or what we call ignition source. So once we have these three things, you have fire. And there are three types of fire that you can have. We have what we call pool fire. We have what we call jet fire. This is jet, not jet. This is jet. We have what we call jet fire. And finally, we have what we call flash fire. Pool fire is when we have fire that is formed around a pool of fuel or oxidants, or around a pool of fuel. Whereas jet is different from that, and also flash is also different. Now we talk about explosion. There are two types of explosion. There's what we call vapor explosion, and what we call another type of explosion known as BLVE. Very important. BLVE and BCE. There are the two types of vapors that we have: vapor cloud explosion and boiling liquid expanding vapor explosion. Vapor cloud explosion and boiling liquid expanding vapor explosion. Two major types of explosion that were very important. Now we get to what we call risks and risk ranking, risks analysis and risk ranking. For you to measure the type of risk or the amount of risk that an individual is exposed or the environment is exposed when you're setting up a factory, or when you're doing something, or when you're carrying out a project, risk is equal to severity times likelihood. What is the amount of impact that this risk is going to pose? And what is the frequency, what is the probability that is going to happen? Whenever you have severity, the amount of impact times the frequency or the likelihood of it happening. When you have the product, you have what you call risk. And in risk ranking, you have what we call severity range, which ranges from catastrophic, with range I, Roman numerical I, critical 2, marginal 3, and negligible, which is the least 4. That is severity. What is the impact that it can cause? It can cause a very catastrophic. That means it can kill somebody and cause damages worth millions and billions. Critical, very bad, can lead to very bad body damage, marginal, not so bad, negligible, very little. Now we also have what we call likelihood range, where we have frequent. That means it can happen often. Probable, lesser than often. Occasional, once in a blue moon. Remote, once in a while. And improbable, never happens most times. Now we have what we call risk ranking. Once you multiply severity with high likelihood, what do you have? Is this risk, is it acceptable? Is it undesirable? Is it acceptable with conditions? Or is it acceptable as it is? That means that the risk is very, very small. You just leave it acceptable as it is. The bad one is unacceptable and undesirable. Then acceptable with condition, you can accept it, but once you're wearing helmets and other protective materials, acceptable as it is, that means the impact is very small. Now, what is that magic number that you have when you have risk at that level? You say you can manage. That number is what we call 1 times 10 to the power minus 6. Very, very important. Environmental exposure and risk analysis, very, very important. Disasters that have happened, and they are not very good, like the Pamex one, Opa, Chernobyl, Piper Alpha, Rice Spangler, Fukushima Daiichi, Petronas, Flixborough. Because of this, you need to do what we call proper risk analysis, hazop, environmental impact assessment, EIA, very, very important. These 3 things are very important. Risk analysis, hazop, that's hazard and operability studies, environmental impact analysis. Whenever you want to set up a factory, you want to do anything, you have to call chemical engineers to study all this before you can set up such things, so that they will not be disasters to the environment. So very, very important. In subsequent classes, we're going to be looking at hazard and environmental, hazard and operability studies. And we're also going to be looking at environmental impact analysis, how you can check risk, so that we know whether this project you want to start is actually worthwhile, or is it going to be something that you start, it will bring money, but at the same time it will kill people. It's very, very bad. So we look at all this, and that is what we captured under the topic environmental exposure and risk analysis. Thank you. If you like this video, please click on the subscribe button, like and share our videos. Thank you, and God bless.